Okay, now let's look at an example on series arrangement, on a parallel arrangement, and on the combination of the two, the series and the parallel. Let's start with the series. The series arrangement, we have been given such a question. Determine the total extension of the system. And the system is this one. We have a spring here, merged with another spring. Then it has a load of 90 newtons. This spring A, this spring B. Now we've been told determine the total two identical springs, each of spring constant. Now we have been told the spring constant, the spring of spring A, the constant of spring A, it is 0.3 newtons per centimeters, and the spring of constant B, the constant of spring B, it is 0.3 newtons per centimeters, because we told that each of spring constant 0.3 newtons per centimeters are arranged in series, and the weight of 90 attached at the end of the spring B. Now the question is determine the total extension of the system of extension, the extension of spring A and the extension of spring B. And but the question is determine the extension of the system. The system means the combination of the two. Now here, I want you to get me clearly. Now here on spring A, we'll find the constant on spring A first, then the constant on spring B. Then the two will add, because this spring will stretch and this spring will also stretch. Now it means the distance the extension that this string stretches, it's also, it can be equal to the extension of this one, but for you to get the extension of the whole system, we have to add the two. That is specifically on series arrangement. We add the extension of each spring when we are dealing with series arrangement. Now let's start with spring A. Spring A will say that force is equals to KE. And the force on spring A, it is this 90. It is attached on spring A. Now our force is 90, is equals to, the constant, it is 0.3 newtons. Now we have 0.3 multiplied by extension. We are looking at extension. Now we'll divide both sides by 0.3, divide by 0.3. This one goes with this one. Now our extension will be 300 centimeters. Same to spring B, because force of spring B is also 90. Extension is also 0.3. Now the force will be equals to KE, whereby this 90 is equals to constant, which is 0.3 times extension. Dividing both sides by 0.3, 0.3, our extension will be 300 centimeters. Now the extension of the system, the extension of the total system, it will be 300 plus 300. This is centimeters, which will be 600 centimeters. That is only in series arrangement. Now let's look at parallel arrangement. Parallel arrangement. For instance, you have been given a spring like this one, another spring like this one. They are both attached to somewhere. Then they are both attached to the load. I think we can just use the 90 newtons. The force attached to it is 90 newtons. Look at the question. Two identical spring, each of spring constant. Now this spring A, spring B. Now the constant of spring A, it is 0.3 newtons per centimeters. Constant of spring B, it is 0.3 newtons per centimeters. Now the constant are also equal. The force the force applied, or the load applied on the spring, is also the same, shared by the two. Now if you look at this scenario, it's all different from this scenario. This scenario means spring A and spring B, they are sharing these 90 newtons. That means spring A, the force being applied on spring A, it is a half of the force being applied on spring B. That is spring A. If you want to find the extension of spring A, let's look at spring A. Spring A will have force is equals to KE. Now, if this one is 90, if you distribute the 90 between the two springs, you will have spring A force being 45 newtons, spring B 45 newtons. Now you will have here 45 is equals to constant, which is 0.3 times extension. Divide both sides by 0.3, divide both sides by 0.3, whereby this cancel with this one and you get extension as 0.3 divided by this one, you will have it as 150 centimeters. I think so. Yeah. Now, if you look at spring B, the force is equals to KE, and the force is 45, which will be equals to 0.3 multiplied by extension. Divide both sides by 0.3, 0.3. Our extension will be 150 centimeters. But under this scenario of parallel arrangement, they are being shared and the system is attached to the two of them. It means that the extension of the system will be the extension of only one of the spring. Because this spring, if it elongates, for example, to this certain distance, let me use a different pen. To this certain distance from here up to here, the extension is 150 centimeters. It means system A also 150 centimeters, it will extend from this point to this point, and the system will be at this point. Now the extension will be equal because the system has extended from this point to this point. But in scenario A, where we had series arrangement, this spring A extended with 300 centimeters and spring B 300 centimeters. Now this length, if it increases with 300 centimeters, it means it will push this spring B to move downwards 300 centimeters. String B also have another extension of on its own. It will extend to another 300. Now the first extension is 300, the second extension is 300. Now the total extension of the system will take 300 plus 300 to get 600. But under this one is only 300. Okay, I think I've explained the scenario of series and parallel. The reason why we add in series the extension to get the total extension of the system, and the reason why we take only the extension of one spring on parallel. Let's look at when we have been given the two combination, the series and the parallel when they are combined together. Let's look at this scenario. For instance, if you have been given such a system, now these are now a combination of the two, the parallel and the series. If we take this one to be spring A, this one B, this one C, then this one D, this one E, this one F, we have another spring down here, remember, and we take this one as system 1, this one as system 2, this one as system 3. Now this is how we go for the question. When we have been given the constant of each spring, spring A, spring B, spring C, up to spring F, the constant to be 0.3 newtons per centimeters. And the force applied now here, the total force applied is 90 for the all springs. Now you have to ask yourself, how is this force being distributed? We say that if you want to find the extension, now we want to find the extension. For example, we have given find the extension of the system. Now this is the whole system, the system 1, system 2, system 3 combined. Now the extension of the whole system. This is what you have to do. We have to look extension of one of the springs on system 1, because system 1 comprises of the 3 systems, of the three springs, that's spring A, B, and C, which are parallel. And you say when they are parallel, we only use one of the springs to find the extension, which will be the spring, the extension of the whole system. Now let's say system A, system 1 I mean. System 1 extension force is equals to KE. Now our force, let's distribute the force. This system 3, it is only using a force of 90 because it doesn't have any spring that it is sharing with. If we go to this system 2, we are having a force of 90 on this system 2, and this system 2 consists of the 2 springs. Now we have to distribute the system 2 with the with this force of 90, 2 of them. Now we have here 45 newtons and 45 newtons. If we go to system 1, it has 3 springs, and the 3 springs are sharing the 90 newtons. Now it means each spring must have 30 newtons, 30 newtons, 30 newtons. I think I could have used a different pen. 30 newtons, 30 newtons, 30 newtons. And this one was 45 newtons and 45 newtons. Then the first one is 90. Now let's say in system 1, the force being used on if we want to find the extension of system 1, we have to use only one of the springs. And one of the springs, the force applied on one of the springs, it is 30 newtons. Is equals to constant on each spring was 0.3. Now we have to use 0.3 multiplied by extension. Now let's divide by 0.3 divided by 0.3. This one goes with this one. Now an extension on system 1 will be equals to 300 divided by 3, that is 100 centimeters. Let's look at system 2. This is the extension on the whole of system 1. Let's look at system 2. System 2, force is equals to KE. The same scenario continues. The force being applied on one of the springs on system 2, it is 45. Will be equals to, now the force, the constant, it is 0.3. The way we have been told that the constant is equal to all of the springs. Multiply the extension, divide by 0.3, divide by 0.3. Now if you divide 45 divided by 0.3, this one goes with this one. Now our extension on system 2 will be equals to 150. Yeah, 150. Let's go to system 3. System 3, constant is equal, force is equals to constant times extension. And our force on system 3, it is not being shared with any of the other spring. It's only one spring being used. Now the force will be 90 is equals to constant, it is 0.3 multiplied by extension. Divide by extension, 0.3 divide by 0.3. This one goes with this one. Now our extension on system 3 will be equals to 90 divided by 0.3, that is 900 divided by 3, which is 300 centimeters, and here was also centimeters. Now we have extension on system 1, extension on system 2, and extension on system 3. And system 1 is in series with system 2, which is in series with system 3. Now we have said that extension in series we usually add. Now we'll take extension in system 1, which is 100, plus extension in system 2, which is 150, plus extension in system 3, which is 300, which will give us 100 plus 150, 250 plus 300, that is 550 centimeters, which is the total extension. The total extension, 550 centimeters on the system. I think this is a very good example that we'll use maybe when you have been given such a combination with both series and parallel arrangement of the springs. Up to that point, I don't think if there is any question. Maybe I can give a question that someone you can try to find out the. Okay, let's look at at this example. This example, maybe if you look at the example, you can think that maybe the example is so difficult. The figure below shows a spring when unloaded when there is no load, then when supporting a mass of 5 grams, and when supporting a stone. Now the question is, determine the mass of the spring, of the stone, the mass of the stone. Now the first thing, it is the same spring. When it is unloaded, it means the length is 6 centimeters. And when it's supporting a mass of 5 grams, the length extends to 8.5. Now let's start with this mass of 5 grams. We'll say that extension, it is 8.5 centimeters minus 6 centimeters. Because I said that extension is as a result of the taking the initial length, you subtract from the final length. And this one you will have is at, if you take 8.5 minus 6, you will get 2.5 centimeters. That is our extension. Secondly, we have been given the force as a result of mass, 500 grams mass. Now our force will be equals to, we have been given mass, mass is equals to 5 grams. If we change these grams to kilograms, what do? We take this 5, divide by 1,000. Then dividing by 1,000, we have to multiply by 10 for it to change in force. Now our force will be, this 0 goes with this 0, will remain with 0.05 newtons. That is our force. Now we say that force is equals to KE. We are looking for K, the constant. Now we'll say constant is equals to force over extension. And our force is 0.05 divided by extension, which is 2.5. If we divide the 2, we'll get the constant as 0.02 newtons per centimeters. This is the constant, and because the spring is the same spring that is when it's unloaded, when we have 5 grams mass, and when we have a stone on it. Now the constant will be the same as to the third scenario, where we have the stone. Now let's look at the stone. We are looking at the mass of the stone. We can say that the stone, we have been given the final length as 7.5, and the initial length of the spring is 6. Remember that. Now we can get the extension when the stone is hung on the spring. The extension is 7.5, the final length, minus initial length, which is 6 centimeters. This will give us extension as 1.5. This is 1.5 centimeters. Now, we have extension, we have constant as 0.02 newtons per centimeters. Let's look for force, which is force is equals to KE. We have our K, which is 0.02, multiplied by our extension, which is 1.5. If we take the 2, if you multiply the 2, you'll get this 1.5 divided by this, you'll get as 3. That is 3 grams. And this is our not 3 grams. Okay, 0.02. If you press to a calculator, let me press on my calculator. I think it is 0.03 newtons. Therefore, our force is equals to 0.03 newtons. And if you want to convert this 0.03 newtons, we have to convert into mass, because we have been given that we have been asked to find the mass of the stone. Now, what do? We say that weight, force is the same as weight, or force is equals to mass times gravitational pull. That is mass times gravitational pull. Now, how do we find this mass? Because we are the one we are looking for the mass. We'll take force divided by grams, gravitational pull. Now, our mass will be our force, which is 0.03 divided by 10, which is the gravitational pull, where we'll have this one as 0.003 kilograms. That is the mass. That is the mass of the stone. Either you can write it in kilograms or in grams. Someone might, if you want to write it in grams, just take 0.003 times 1,000. This will give us 3 grams as the final mass of the stone. I think you have gone through the procedure and you find everything right, correct. I don't think if there is any question, and I think if some of you can find such a questions or different questions from the same topic, you can do away with the question, because this topic, I'm done with it. Let me appreciate you and ask you to subscribe and share so that you can find more and more, both in physics and mathematics. Thank you for listening, Professor Bill.